Hello, my name is Levy, and this is a WPA exploit demonstration for CIS5372. The goal of this demonstration is to demonstrate how to find and monitor wireless networks to attack, locate clients on the network, deauthenticate or kick clients off the network to capture a handshake attempt between the client and the wireless access point. And once the WPA handshake has been captured, we will use a password list to try and brute force or crack the handshake hash to discover the password. The tools that I'll use today are the Kali Linux penetration testing operating system, the AirCrack NG suite of tools that come with Kali, and an Alpha AWS 036NH USB Wi-Fi adapter that I purchased from Amazon.com. From a terminal inside Kali Linux, we're going to check to make sure that the wireless interface is up, and it is up. It's WLAN 0. Then we're going to run the command airmon-ng start WLAN 0, and as you can see, the wireless interface is in manage mode and we want to put it in monitor mode, and that's what this command is going to do. So now it is in monitor mode, and you'll see that it has a new name, WLAN 0 mon. And just to double check, you can see now that it is in monitor mode. So now that the interface is in monitor mode, we want to go ahead and monitor the networks that are around us to see what's a good network to attack. Next, we're going to use AeroDump NG on WLAN 0 mon, the wireless interface, to packet capture some of the 802.11 frames that are going to be going back and forth. And in particular, we want to note the BSSID on the left side. That is the MAC address of the wireless access point. We're going to need that, as well as the channel and the network name. One of the things that I like to do is put all the networks into a nice list so that it's easier to get all the BSSIDs and information. The network that I have selected here is Dr. Evil, and that's my home network. And you can see the BSSID for the access point. It's a WPA2 network. So what we're going to do now is we're going to run the command aerodump -ng, and aerodump ng will allow us to monitor just this network and then look at all the clients that are connected to the network. So the -c in the command here, that -c is the channel. It's on channel 6, and then we're just going to copy and paste the BSSID, which is the access point ID. Next, we're going to add the -w flag, which will specify the location where we are going to output the packets that are captured while monitoring this particular network. And I'm just going to throw them on the desktop here. Now we'll use AeroDump to monitor the clients that are connected to the network. And as you can see here, there are 4 clients. We've got the BSSID here, and then the MAC ID of the clients is the station. Now that we have a list of associated clients that are connected to the wireless access point, we're going to select the client, and we're going to use airreplay-ng to send deauthentication packets to that client. A deauth is a frame that is a part of the 802.11 framework, and what it basically does is a router would send that to a client, which would say, hey, you're disconnected, and it will force the client to make a reconnection attempt. And that reconnection attempt is what we're trying to capture, because during that reconnection attempt, there will be a WPA handshake. The handshake happens when the client is trying to connect to the wireless access point, and this happens during the first connection and whenever the client gets disconnected. AirReplay will send the deauth frames, which will tell the client that it has been disconnected, and so it will try to reconnect. During that reconnection, the WPA key will be exchanged with the wireless access point, and we can decrypt that key using a brute force attack to figure out what the wireless password is for the network. After running error replay and deauthorizing the clients, we've captured an attempt to reconnect, and that's the WPA handshake. The unique identifier identifies the actual packet that contains the handshake, and because we captured the packets, it's easy for us to use the aircrack tool to go in and try to decrypt the packet. Now I'm going to start aircrack, and it will try to brute force decrypt the WPA key. I have to specify a word list. I have a very large list called the super WPA list. And as you can see, it's going to continuously try different combinations to match the hash that's generated by the WPA key, and thus let us know what the actual plain text password is. Now, this can take a very long time, and what a lot of people do is they'll either try to run it on a GPU system, which will be faster, or they will upload it to a website where they can pay to get the password a lot quicker. What I'm going to do though is I have a file that contains the actual password, and so I'm going to use that file to show you that it can actually decrypt the WPA key if that password is in the list. So in this password list, which is fairly short, I've added a bunch of passwords, and at the end I will add the actual password for the network, which is Bigglesworth. That's Dr. Evil's cat. And then I'm gonna save the list, and then I'll just feed the list to aircrack. And there you go. Just like that, it went through the entire list and it was able to match the WPA key to the password that was actually in the list. So make sure your passwords are sufficiently long enough and complex, because they're very easy to crack when they're just alphanumeric characters or they're very short. This concludes my demonstration.